So this is exercise 2.2. Exercise 2.2 in our series on solving questions from Quantum Optics book by Professor Mark Fox. So this question says a linearly polarized laser beam propagating in air has an intensity of 10 to the power 6 watt per meter square, 1 megawatt per meter squared. So the question says calculate the amplitudes of the electric and magnetic fields within the electromagnetic wave. So let us solve this question now. So what are we given? We are given the value of intensity. Intensity is 10 to the power 6 watt per meter squared. Now we know, we have seen in this book, the formula for intensity is given as follows. So this is the formula for intensity. Why is this so? Because the magnitude of pointing vector gives us the intensity. So we need to find out the amplitude of the electric and magnetic fields. So the amplitude of electric field is nothing but Ex naught, and this I that I have written is nothing but the average pointing vector average. This is the intensity. So from here we can calculate the value of Ex naught. So let us just solve this. N is the refractive index. So N is the refractive index. So refractive index of air is roughly taken to be 1. This is refractive index of air, which is roughly equal to 1. C is the speed of light, and epsilon naught is the permittivity of free space. So let us rearrange. So this is the expression for the amplitude of electric field. Now we need to plug in the values and evaluate it. So let us do that. So the value of C, we all know, is 3 into 10 to the power 8 meters per second. The value of the permittivity of free space, is roughly equal to 8.85 into 10 to the power minus 12 farads per meter. The SI unit of permittivity, SI unit, is ampere squared second to the power 4 kg to the power minus 1 meter to the power minus 3. This is the SI unit of permittivity of free space. A simpler way to remember this value is that 1 over 4 pi epsilon naught is roughly equal to 9 into 10 to the power 9 Newton meter squared per Coulomb square. This is just a simpler way to remember the values. So let us put in these values in the calculator and see what do we get. So putting in these values in this expression for Ex0, we get the value of Ex0 to be roughly 2.7 into 10 to the power 4 volt per meter. So this is the value for amplitude of electric field. The first part of the question is done. This is amplitude of electric field. Now we need to find out the amplitude of the magnetic field. So the magnetic field is given in terms of the magnitude of the electric field by the following expression. This is the expression. So notice that if electric field is along the x direction, then for free space propagation, this is free space propagation in air, we will have the magnetic field to be orthogonal to the electric field. So if this is in x direction and if we assume that the propagation is along the z direction, then we will see that the magnetic field will be along the y direction. So that's why I've written by0. So again, n we will take to be 1, c is 3 into 10 power 8 meters per second. So if we put in these values, we get the value of the magnitude of the amplitude of the magnetic field to be roughly equal to 9.1 into 10 to the power minus 5 Tesla. This is just substituting the values in a calculator and we will get the following. So this is amplitude of magnetic field. So the important formula used in this question was the following. Where we use the fact that this side is the magnitude of the average pointing vector and this value, the magnitude of the pointing vector, happens to be equal to the magnitude of the intensity. This is from the definition. And the next formula that we have used is the following. This governs the amplitudes of the electric and magnetic field and how they are related with each other. So this solves the question. This was a numerical question and we have found out the values.